Hello guys, this is Mr. Leshin and this is SS1 class. The last time we discussed about resistors and cells and the arrangement of what cells and resistor, and we talked about there are two ways by which you can arrange cells and resistor, which are the what series and what parallel arrangement. Cells in series, uh, they have properties different from what those ones in parallel. That is in cell series, the same current flows through the individual cells as the same as the total current in the circuit. But in the potential different current flows through the individual the cells. And in resistance in series and parallel, the total resistance of resistance in series, in case you have like three resistance, let's say R1, R2, and R3, the total resistance is given as the sum of the individual resistance, and the same current flows through and in series arrangement of water resistor, while different voltage across, different voltages across. But in the case of resistors in parallel, the total resistance is given as what reciprocal of the total resistance is given as the sum of the reciprocal of the individual resistance. That is, if you have three resistors arranged in parallel in a circuit, their total resistance is given as what? Let's say RT is the total resistance to what 1 over RT equals to what 1 over R1 plus 1 over R2 plus 1 over R3. So to give you what the reciprocal, in which the least the total resistance is smaller than the least resistor. The resistance of the resistor, individual resistor. The total resistor is smaller than the least resistor. And in parallel, there are different current flows through them, while same voltage across. So these are just the properties of arrangement of cells and resistors in series and parallel. Well, this week we'll be looking at another topic entirely. This is three electrical energy and power buying electric currents, electrical energy and power buying electric currents. I'd like you to take note of some words here, which is energy and power. Basically, energy is the ability to do work. Energy is the ability to do work. So in electricity, there's a relationship between the electrical energy and work done. We relate them together. We relate them together. We take them as one. But you can represent the electrical energy as work done, the ability to do work, the work done. That power is the rate of consumption of energy. So we look at how to calculate energy consumed, how to calculate energy consumed in this topic. We'll just I'll take you through the learning objective. Take you through the learning of what we have set to achieve this week. At the end of the lesson, students should be able to explain the concept of electrical energy. The concepts I already told you about that. The work done, the electrical energy, the basics of electrical energy, how to derive the formula, and how to derive the formula from Ohm's law, and solve questions. We just take one question from there, and the concept of electrical power and how it is being consumed. I will explain that too. So we go to electrical energy. So electric energy, this is the ability to do work, and I told you related to the work done. So given that the potential difference, we all know what potential difference is. This is the work done in moving a charge from one point to another in a circuit. Moving a charge measured in Coulomb Q from one point between 2 points in an electric field. That is V equals to W over Q, where V is the potential difference, and the unit of potential difference is volts, and the work done is W, and the charge is Q, where V is the potential difference. I said that, and the unit is volts. So the expression of from this expression, V equals to W over Q can amount to W equals to VQ. This expression here, if you make W the subject of the formula, you have W equals to VQ. And I said earlier, W is the work done, which equals to potential difference times charge. We are trying to find the expression for the work done. We are looking for the expression for the work done or the electrical energy. And recall, I equals to Q over T. Current equals to Q over T. In our previous topic, on the week 1 topic, we talked about electric current, which is the rate of flow of charge along a conductor, the rate of flow of charge, which equals I equals to Q over T, where Q is the charge and T is the time. I stands for the current. So if you make Q the subject of formula, you have Q equals to IT. Q equals to IT. So replace the Q in equation 2 with the Q in equation 1. Replace the Q in equation 2 with the Q in equation 1. So you have the expression for work done. Doing that, where Q is the charge, I is the current, and T is the time. Please take note of this parameter and their meaning. Q is the charge, I is the current, and T is the time. So from both expressions above, we can derive the expression for work done or electrical energy. So this, if you replace Q, this Q equals to IT with Q here, So you have W equals to what? V open bracket what? IT. V open bracket IT. You have V open bracket what? IT. From those expressions, two expressions, if you combine them, we have what? V equals W equals to what? V open bracket IT. Where W is what? I said earlier, W equals to what? Work done. I is the current, V is the potential difference, and T is the time. So in this case, you have W equals to 1. This is an expression for what? Work done, what? Electrical energy. In the case you are given a question to calculate the work done or the electrical energy, and you are given expression or parameters like are given the current, are given the potential difference, and you're given the what? Your time. It is very, very easy. Just insert those information in this formula. That is W equals to what? IVT. But further, we can have another expression. Can be given questions whereby you are not given the potential difference and you have to calculate the work done, whereby what the information on current is provided, the time is given, and the resistance is also provided. So this is what V equals to R. You recall from your Ohm's law, the current passing through a metallic conductor is directly proportional to the potential difference. So this is the expression for what Ohm's law. That is what V equals to what IR. V equals to what IR. So here, make V the subject of formula here and replace V in equation what 3, that is IVT. Replace V equals to what IR in what this question you have what W equals to what I open bracket IR bracket T. So which will now give you this what expression, that is W equals to what I squared TR. I squared TR. I would like you to what try it out, insert do the expression and make what W the subject of formula in from equation 3, replacing V with what equals to what IR. So you have what I square equals to I squared TR, where I is the what current, T is what time and resistance. As I said earlier, you are given an expression whereby to calculate the work done or electrical energy, and you are given information on current, which is I, time, which is T, and R, which is the resistance. So this is a formula to introduce. And we can go further. You can be given information on potential difference, T, and the resistance, whereby current is what missing. You can also find your you can also find your work done. Just replace I equals to what V over R. I equals to VR is coming from this Ohm's law. That is make I the subject of formula divided by side by R here. You have I equals to what V over R. So putting the expression, you have what W equals to what V squared T over what R. V squared T over R. So the question is, the notice the expression 3, the expression 3, expression 4, expression 5 gives what the expression for what work done or electrical energy, and the unit is what joules. The unit of what electrical energy is what, is what joules. The unit of what electrical energy is given as what joules. So we'll go to power. I believe we understand the concept of what energy now. So electric power, this is the rate of what by which energy is being consumed, or the rate of what doing work. The rate at which energy is what being consumed is what is the power, and it can be expressed, given an expression of what work done over time from the formula, from the formula rate at which what work is being what done. That is work done over what time, and you know the formula for work done given here is what. You take the formula equals what I from expression 3, equation 3, IVT give you what work done equals what IVT over T time. Cross multiply T takes T, and we have what P equals to what IV. So the rate power is given as what the product of what current times what potential difference. That's another expression. But from the definition, is the rate by which energy is being what consumed. So as power can also be expressed in other form. Power can also be expressed in another form. Look at the other expression of what work done. Here we have what I square TR. I square TR. I square TR. So replace I square TR as work done over time here. So we have what we have in this expression. Let's say I square TR. T will cancel T. We have what I square R. If you use the fifth expression, that is V square T over R. V square T over R. If you replace work done as what V square T over R, here you have what V square over what R. You have what V square over what R. So these are the three expressions for what power also. By this parameter, you can be asked to calculate what power, given what current and voltage. Use this. Can be asked to calculate power using what given voltage and what resistance. You use this. Can be asked to calculate what power using what current and what resistance. You use this. So the unit of power is what watts. I already told you the unit of what energy is what joules. The unit of what energy is what joules. And so 1 watt is what power consumed in electric current. One joule of work done is what in 1 second. 1 watt is the power consumed in an electric current. When 1 joule of work done in what 1 joule of work is done in what 1 seconds. So let us go to the next slide, which is what buying of what electrical energy. And this is going to tell us how to calculate, how you calculate the power consumed, how to charge the charge on what the power consumed. They are using that this kilowatt per hour in your house. How do they charge you? What is the cost? What is the cost of this energy consumed in the house? Let me take the note in IKEA, IKEDC supplies electrical energy to every house through installed meter. We all have installed meters in our house. If you don't have the old one, you have your prepaid meters now. This is what we are talking about, the installed meter. And from your prepaid meters, when you buy a token, and you install it on your prepaid meter. So they probably in 2 weeks you see that it's exhausted. So this energy, there's a way they calculate the cost. Probably a naira on the is to a charge. Probably a naira to 1 kilowatt of energy consumed, or a 10 naira to a quantity of energy consumed. So that's what we are talking about here. So the meter measures the amount consumed in kilowatt per hour. The meter measures the amount consumed in kilowatts per watt hour. In case you are using 1 kilowatt per hour, probably on your token, you recharge, let's say 1,000 naira, and in your house you have so many appliances, so probably are charging 5 naira for 1 kilowatt per hour. So you can easily calculate like these appliances give this. You can easily calculate the cost of what energy you use in your house. So, and by this it is easier to calculate the cost of what energy consumed. The meter makes it easy to calculate the cost of what energy consumed in terms of what kilowatt per hour. Look at it, 1 kilowatt per hour is the amount of energy. 1 kilowatt is the amount of energy supplied by a rate of 1,000 watts for 1 hour. 1,000 watts for 1 hour. If we have kilo, it means 1,000. 1 kilo. 1 kilowatt is 1,000 watts. It's a way of is a measure. 1 kilowatt is 1,000 watts. So it says 1 kilowatt is the amount of energy supplied by a rate of working of 1,000 watts. The power of 1,000 watts for 1 hour. That is 1 kWh, 1 kilowatt hour. 1 kilowatt per hour. So that's it. So is the electrical energy consumed by an appliance when power of 1 kilowatt is used by an appliance for 1 hour? They want to calculate the amount of energy from 1 kilowatt for 1 kilowatt hour. It's easily the energy consumed in 1 kilowatt per hour. The energy withdrawn from the power is 1 kilowatt hour. 1 hour is 60 times 60 seconds. So this is it. It is measured like this: 3.6 times 10 raised to power 6 joules. That is the energy in 1 kilowatt per hour. 1 kilowatt of power is 3.6 times 10 raised to power 6 joules. Just follow the expression. 1 hour is 60 times 60 seconds. 1 kilowatt is 1,000 watts. From here, expresses 1 kilo is 1,000 watts. So 1 kilo equals 1,000 times 60 times 60 will be 3.6 times 10 raised to power 6 joules. 3.6 times 10 raised to power 6 joules. So this is the concept of energy, power, and now energy consumed is being calculated. The cost, the charge on it is how it's being calculated. So there's a given charge on. In case this 1 hour, 1 kilowatt is given as probably 5 naira. There's a way you just multiply it by okay, this is the amount of energy we consume. We consume 1 kilowatt per hour, and it's 5 naira. If you consume 10 kilowatt per hour, you just multiply by by 5 naira. So you know that okay, we have used 15 naira. So they have let's say 1 kilowatt per hour is 100 naira, and you have used a certain amount of energy just for you to calculate it. That is how they calculate, how the IKEDC calculate the charge. And you using your prepaid meter, you can easily cross check and check your meter. What's the power that we have consumed? And just calculate it to get the amount used. So this is it. Energy is the ability to do work, and we've gotten the expression for energy because W equals IVT, where I is the I is given as the current, V is the potential difference, and T is the time. Same as power. Power is the rate at which energy is being consumed, and the expression is P equals to IV. You just need to understand these basics very, very well. This is what we'll be talking about this week. Just understand the basics very, very well on energy and power. So it will be easy for you to run down go to cost calculation of energy and consumed. Let me just take one example and we'll close for the week. So an electric heater, take this example. An electric heater takes 4 ampere. The units of current is ampere. So you note that the current we're talking about here is I equals 4 ampere. You write that out. I equals 4 ampere. When operated on the 250 volts. Now you know that your volt is 250 volts. You write V equals 250 volts supply. First up, calculate the cost of the electricity consumed. Calculate the cost of electricity consumed at 10K. That is the cost, the charge. For per kilowatt hour is what? 10K. 1 kilowatt hour is it's equal to what? 10K. Let's say 10 kobo. So 1 kilowatt hour is amounts to what? 10K. So when the heater is used for what? 4 hours. 1 kilowatt hour is what? 10K. So now we are asked to calculate the power consumed, the what? The energy consumed, the what? In 4 hours. The energy consumed, the what? In 4 hours. So what do you do now? First, you calculate the power. You have been given what? You can easily express it. You have been given what? I, and you have given what? V. In case you want to go straight and use your formula for what? Energy. You can easily calculate the energy from there that you have given what? I, V, and what? T. You know, recall, W equals to what? I, what? V, and T. I times what? V times T. And you are giving all the parameters here just for you to calculate what? The energy consumed. Then you want to calculate what? The cost of what? Electricity. That is the energy consumed times what? 10K. So this is it. Solution. P equals to what? IV. From the formula, P equals to IV, and we're given a current of what? 4 ampere, and V equals to what? 250. V equals to what? 250. If you must, therefore, P equals to what? 4 times. You insert them in this expression, you have 4 times what? 250, which was what? 1000 watts. 1000 watts. This is what? 1 kilowatt already. I told you 1000 watts is what? 1 kilowatt. Let's just go through the expression again. From the notes, 1 kilowatt is the amount of energy supplied by a rate of working of 1000 watts. So you can easily convert it to 1000 watts is the same as what? 1 kilowatt. So this is what? Energy consumed by liter in 4 hours. So power times time, which is what? That is IV times T, is what? Energy. Energy is what? This is what? 1000 watts times 4 hours is what? 4 kilowatt hour. That's what? 4 kilowatt hour. 4 kilowatt hour. So since 1 kilowatt hour equals to what? 10K. So it is therefore easy to calculate the cost. That is, if 1 kilowatt costs what? 10K, then 4 kilowatts will cost what? That is what? 4 times what? 10K, which will now give you what? 40K. So the cost of energy, the cost of what? Energy, the calculated cost of electricity consumed in 4 hours is what? 40K. So that is that about that. I would like you to go through the notes again and listen to the video once again, go through it and go through your notes and understand it. I've sent some questions with this analysis and the formula provided here. We'll be able to solve what? Further questions. Recall the expressions for what? The 3 expressions for what? Energy, the 2 expressions for what? Power. You'll be able to what? Calculate or do any calculation or solve what? Any further problems of what? Energy and power. Thank you for your time. I will see you in the next class. Bye.